In this lesson, we'll be discussing how to evaluate the limits of a function analytically. There are two methods that can be applied here. The first one is by direct substitution. For example, if you are given to evaluate the limit as x approaches 2 of 3x all over x squared plus 1. To evaluate this, we'll replace the value of x directly into the function. So as x approaches 2, we are going to have 3 into multiply 2. So anywhere we see x, we'll replace it with 2 all over 2 square plus 1. So this will give us 2. 3 times 2 is 6 and 2 square is 4 plus 1, 5. This gives us the final answer. Let's take another example where we have that the limit as x approaches 3 of x cubed. Okay, let's take x squared first, minus 9 all over x minus 3. And you are asked to evaluate the limit of this function. Now, if we try to do direct substitution here, we are going to have as x approaches 3, 3 square minus 9 all over 3 minus 3. And 3 square is 9 minus 9, that is 0. And 3 minus 3 is 0. You see, this function becomes undefined, and that is not reasonable. You don't want that. So direct substitution cannot work here, and that leads us to the second method, which is factorization. Now let's properly solve this by factorization, where we find the factors of the numerator. So if we have the limit as x approaches 3 of 3 squared of x squared minus, what number can we raise to 2 to give us 9? That is 3 to the power of 2. That will give us 9 all over x minus 3. So you can see that at the top we are already having difference of squares. So we are going to have the limit as x approaches 3 of x minus 3 squared all over x minus 3. And you know, difference of square can as well be written as if you have a minus b squared will give us a minus b multiply a plus b. So this is another way to write difference of squares. So if we have that at the top, we can have the function evaluating further. We are going to have the limit as x approaches 3 of x minus 3 multiply x plus 3 all over x minus 3. We can see that this can cancel out, so that what we have left will be the limit as x approaches 3 of x plus 3. Now we can go for that to do direct substitution, meaning as x approaches 3, we are going to have 3 plus 3, right, which will give us 6. And this is our final answer. As a matter of practice, you can try this exercise pause the video, and when you return, you watch the solution. If you are given that f of x, it's equal s squared plus x, and g of x is equal x plus 1, and you are asked to evaluate the limit as x approaches 2 of f of x plus g of x. So pause the video now. When you return, we solve it together. In solving this, we can have, it's just the sum of functions. We are going to have the limit as x approaches 2 of x squared. Is that s squared plus x, which is f of x, plus g of x, x plus 1. So we just collect the like terms there. We are going to have the limit as x approaches 2 of s squared plus x will give us 2x plus 1. From here we can do direct substitution. So as x approaches 2, we are going to have 2 squared plus 2 times 2 plus 1, and this will give us 4 plus 4 plus 1, and this is 9, which is the final answer. Let's take another example where we are given to evaluate the limit as x approaches 2 of x to the power of 3 minus 8 all over s squared minus 4. Remember, if we do direct substitution, we are going to have 2 raised to power 3 minus 8 all over 2 raised to power 2 minus 4, and this will give us 2 times 2 times 2, that is 8 minus 8, 0, and 2 square is 4 minus 4, 0, which is undefined. So this cannot work. How do we do this? We must factorize, right? We must factorize. So we are going to have the limit as x approaches 2 of x cubed. What number can we raise to 3 to give us 8? That is 2. So 2 to the power of 3 all over x squared. So we can see even at the bottom we have difference of squares. So what number can we raise to 2 to give us 4? That is 2. 2 times 2 will give us 4. So if we have this, we can rewrite this. We can have the limit as x approaches 2 of x minus 2 cubed all over x minus 2 squared. Now we already know for a difference of squares, at the top we have difference of cubes, and difference of cubes, if we have a minus b cube, can be written, if you expand this, we are going to have a minus b multiply a square plus ab plus b squared. And this is the expansion of difference of cubes. So if we apply that here, we are going to have the limit as x approaches 2 of x minus 2 multiply x squared plus 2x plus 2 squared all over, and we know that the difference of square is x minus 2 multiply x plus 2. If we go further to expand this, we are going to have that these can cancel out, so that what we have left will be the limit as x approaches 2 of x squared plus 2x plus 2 squared is 4 all over x plus 2. Now as x approaches 2, we can now do direct substitution. Here we will have 2 squared plus 2 times 2 plus 4 all over 2 plus 2, and this will give us 2 squared will give us 4. 2 times 2 plus 4 plus 4 all over 4. 2 plus 2 is 4. So this will give us 12 all over 4, which is equal 3, which is our final answer.